Hello everybody, today we will be talking about the rules of inference. This is going to be the last part, or actually second to the last part of the logic packet that we're going to be doing. So I want to, so far we've talked about how to set up the truth table, and also what are some of the rules for the truth table that we came up with the operations that we had, so the and, the or, the if and then statement. But now we're going to look at how to actually write a proof that will help us transition again into actual geometry. So there are going to be four things that we're going to be talking about here called the rules of inference. These are basically going to be the things that you're going to be using in order to do the proofs. So they're listed right here. The first one is going to be called modus ponens. The second one is modus tonen. And then third is simplification. And then the last one is called disjunctive syllogism. Now, for all of these right here, they actually, it's a pretty long name for each one, and it's a little bit hard to recognize which one's which. So we're just going to kind of compact it by calling them by their initials. So for example, modus ponens, we'll go ahead and call it MP. Modus tonen, we'll call it MT, and so on and so on and so on. So let's first start by seeing what they do and how they are going to be, how they work out. So I kind of wrote it out for each one of these, and let me kind of explain for each one then. So again, we're going to have two statements right here. A, which is going to be represented by I am pretty, and B, which is represented by I am smart. So if I were to say A or B, then that means that I am pretty or I am smart, one of those two, right? So all of those rules that we've learned, it still applies. But anyhow, let's look at the first one, modus ponens, okay? And let's go ahead and read the statements then. Now, what's given would be this right here on top, okay? So this is right here, the given. And that means that right here, this is going to be my conclusion. So meaning what I can get out of it if I know what's given. So for example, in the first one, it says that if I am pretty, then I am smart. That's basically what A implies B mean from the last section. If I am pretty, then I am smart. Well, we also know that you are pretty. So then that means if I put the two statements together, if I am pretty, then I am smart, and I know that I am pretty, then therefore I am smart. So the conclusion is supposed to be B in this case. Okay, so hopefully that one isn't too bad. Now, modus tonen is kind of like the backwards of that. So this time around, using the same setup, but let me go ahead and change the variables back to A and B because those are the examples that we're using. We have also given A implies B, so that statement is still there. So if you are pretty, then you are smart. It's still true then. But this time what's known is that you are not smart, okay? Or it is not true that you are smart. Well, taking those two statements, combining it together, if you are pretty, then you are smart, but you are not pretty. But you are not smart, then therefore you are not pretty then. So that means that the conclusion is going to be the negation of A, the negation of the if statement then, okay? So the idea is anytime you have two statements where it's A implies B, and then you have either A or you have negation of B, you can combine them together to get a new conclusion out of it. It's like kind of combining like a system of equation in a way, okay? Okay, let's look at the next one, simplification, or just plain old S. A and B, if I read it out loud, then that means that it is I am pretty and I am smart. The conclusion you can get from that is that if you are pretty and you are smart, you can choose either one of those. You could just say that you are pretty, or you could just say that you are smart. So that's why I say the conclusion is choose A or choose B. Technically, you can use both if you want. Okay, if you are a boy and you are 16, then you can just say simply I am a boy for the sake of using that part of the statement, or you can say I am 16 for using just that part of the statement. Okay, so that's simplification, and that's using an and scenario. The last one is the disjunctive syllogism, or DS for short. I think that's a little bit easier to say. If I am pretty or I am smart, but I am not smart, then therefore I must be pretty. So that one is kind of like saying, hey, you're either A or B, and if you're not B, then you have to be A. Okay, so that's probably the simplest way I can kind of conclude it then. So there you go. That's going to be the conclusion. Okay, so what we're going to do is we're going to use these guys to help us write the proofs for the following over here. So these right here would be an example of a proof. Now, this is just kind of like the bare skeleton of it. So once we get the hang of it, then we can go ahead and do something that's a little bit more applicable, I suppose then, okay? And you're going to see actual words and hopefully it'll make sense. So what we have here is the following. We have given A and B, we have B or D, and then we have C implies negation of D. With those three statements put together, or with those three statements given, I want to prove B as a result. Okay, I want to prove B as a result. So what I want to do is I want to combine these three statements together in a way so then that way I can see how to actually write the proof. If you want, you can probably take a moment to pause the video and see how can we possibly use what we just said over here, right? These four in any fashion to combine them together. Okay. Well, assuming that you did that, or if you're not sure how to do it, then let's try to do this together. Here's what I'm going to do. I'm going to go through each one of these statements and see if there's something that I can use with them. So for example, I noticed like the first statements over here, A and C. Now, according to S simplification, what I can do is I can say strictly A, I can just choose that, or I can just say strictly C, I can just choose that. And that right there is going to be beneficial because if you look around, you'll notice that in the third statement, there is a C that I can use. So here, let me kind of like, write this out as a flow chart. So for A and C, what I'm going to do is I'm going to use simplification to get just C out of it. And then using the statement C implies negation of D, I'm going to combine these two together, right? I'm going to combine these two together because if you look at modus ponens, right, you have an if and then statement, and then you have the if part of it, so you can get the conclusion out of it. So here, just kind of combining these together again, C, and C implies negation of D. So from modus ponens, then that means that I can know the negation of D. And then finally, for the last step right here, which I will put in blue, right? We also know that we have B or D, right? So if I take those two and combine it together right there, then that means that, hey, if it's not D and it's B or D, then by the last one, disjunctive syllogism, then that means that it's going to be B as a result. And hey, there it is. That's what I want to prove then. So this right here is just kind of like a little rough draft as to what our proof is going to look like. It's the same thing as like say if you write an essay, you want to write a draft first just so you can get an idea of the skeleton, and then afterwards you then write the actual proof. Okay, so let's go ahead and put all those together because I see everything already, and now we can go ahead and set up a proof for this. So here is what your proof actually looks like. So you have a two-column proof. That's what this is called. So we usually have not the given. We usually have this is called statement, and this is called reason. Okay. So let's go ahead and go through as to how we're going to fill this out. Now remember, what I want to do is I want to take all of what I just said right there and apply it to this two-column proof. So the first thing that I did was I said, hey, let's look at A and C. So that's going to be my first statement. And there's no technical reason for that. That's really just given, right? Because that was part of the list of things that we know. Now, the next thing after that, we said use simplification to take just C out of it. So that's going to be my next statement. So that means I'm going to go ahead and just take C. Right? I could take A, but the problem is it looks like A is not going to lead anywhere, so that's something that I don't want to choose. So here, my reason would then be simplification. Simplification. Okay, just writing it all out, or you could just say just plain old S. Okay. Once we have that, then we take the next part of our flow chart, kind of, and combine it with what we just know. Number 3. Would then be we say C implies negation of D. Again, that one right there, that's given, just like number 1, because that was from the very beginning. Well, number 4, we say that from step 2 and step 3 right there, we can take those two combined together and conclude the negation of D. Okay, so doing that according to the flow chart, this one right here combined with this one right here, using MP would give us negation of D then. So this is going to be modus ponens, and that's going to be MP for short. Okay, and sometimes what people like to do is they also like to write down the steps for it. So that's looking at step 2, 3, and step 4. That part is not necessary, but it's just good for reference for other people. All right. So as of right now, we're at this part of the proof. Okay, we have negation of D. And then finally, it looks like we're going to go ahead and take the last given, right, which says B or D. So that part is going to be given. And from there, if you look at step 4 and step 5, we know it's not D. We know it's either B or D. So then the conclusion is that if it's not D and it's B or D, then it has to be B. So the reason for that is supposed to be disjunctive syllogism. So DS for short. And again, I'm just going to go ahead and write. It was because of looking at step 4 and step... Oops, sorry. Ooh, went all the way up at the top. And step 5. Okay? All right. So now let's go ahead and put some skin onto the skeleton so you can see how this actually all works out with actual words and everything. Okay? So here is an example that you might actually see instead. Given, you are smart or pretty. If you are smart, then you eat chocolate. It is not true that you eat chocolate and I like pizza. Prove that you are pretty. So this right here is basically just exactly the same thing as what we did in the previous problem, but now we actually have actual statements. So I think the best thing that we can do is take these statements and write it in logic statements, so that way we can think about it the same way as we did for the previous problem. Okay. So again, if you want to pause the video to kind of write out each statement as its own, if you want to write out each statement as its own logical statement, and then afterwards set up the proof, go for it. But if not, I'm going to go ahead and start right here. Okay. So first one, you are smart or pretty. So let me go ahead and say that S is going to represent smart, and pretty is going to be represented by P. And we have or, so that means it's going to be S or P. So that's going to be my first statement. Now, the second one, it says that if you are smart, then you eat chocolate. So maybe I can represent it by something like, say, S, and then we have imply C over here. The third statement says that it is not true that you eat chocolate and I like pizza. So as a statement right here, it's going to be the negation of C and P. Actually, I don't want to use P for that one. Let's go ahead and change something else for pizza. Let's just say L then for liking pizza. Okay. Now, be very careful about this part right here. Remember, I said it is not true that you eat chocolate and I like pizza. Some of you guys might thinking, okay, is it going to be the case that you don't eat chocolate and you don't eat pizza? No, because remember, we want to look at each part of these as like a word for word for the logic statement. So it is not true that, so that's going to be the negation. And then this part is going to be eat chocolate, so that's where the C comes in. As soon as you see the word and, then that means it's going to be, the symbol and. And the last part of the statement, that's just going to be L. If it was the case where it's like, it is not true that you eat chocolate and you like pizza, like both of them are negation, it would have been represented as negation of in parentheses C and L, like that. Okay, but it's not the same thing. Okay, so let me go ahead and erase that right here, and right here, and right here. So there you go. Okay, and in the very end, I want to prove that you are pretty. So that means that my last statement, sorry, not the last statement, the conclusion, right, at the very, very end of the proof is that I want to prove P. Well, we have everything set up just like we did before. So what I want to do is I want to create a flow chart just like just like what I did before. Okay. So let's go ahead and write it all down. So given once again, let me just kind of write it out. We have S or P. We have S implies C. We have negation of C and L. And then we also have prove that it's going to be P. Okay. So again, thinking about strategy, let's look at what's given and what we can extract by combining two or more information. Now, again, just kind of like similar to what we had earlier, I noticed that we have an and statement, and that's usually really a good thing because we can choose either one of those then. Just like in the previous example, you see negation of C and you see L. You can choose either one of those two, right? Because of simplification. Now, in terms of usefulness, I don't think L is going to be useful because I don't see that as any part of the given. But the negation of C, I see that as something that we can possibly use. We can use it right here in the second part. And if we know the negation of C, then we can combine those two together to get negation of S. And hopefully then would give us the last part over here. Okay, so let's go ahead and draw the flowchart so you can see all of this in action then. Okay, so first what I said was let's go ahead and take negation of C and L. From there, we're going to go ahead and use simplification to grab just the negation of C. Once we have the negation of C, I'm going to combine it with the second part of the statement, which is located right here. So S implies C, right? So that's this guy. And we're going to combine these two together. Since it's going to be S implies C, meaning if you are smart, then you eat chocolate. And since you don't eat chocolate, then therefore you are not smart. Okay? So repeat it one more time. If you are smart, then you eat chocolate. So that statement is true. We also know that you don't eat chocolate. That statement is also true. So therefore, you are not smart. So the combination of those two put together is that you're going to get the negation of S. Okay? Now, let's go ahead and take the third part of it, the puzzle, and put it all together. So this guy is going to go over here. We know that it's negation of S. It's S or P. So when we combine those two together right there, right? Oh, and by the way, this one right here was using MT, okay? Now, looking at what we have right there, if it's not S and it's S or P, then that's going to be P then as a result. And that's because of disjunctive syllogism, or CS, or DS, okay? All right, so we have the proof, we have the outline. Let's go ahead and see if we can write it all up. Okay, here we go. So here's your statement and reason. And again, feel free, just feel like a broken record. If you want to stop and try to write this on your own, go ahead and do so, because then you can just fast forward or watch it afterwards to see if you got it correct. All right, so starting from the very beginning, we said, number one, go ahead and take the statement, I do not like chocolate, and I like pizza. Okay, so for that one, we just grabbed it from the given, so that's literally just given. Then from that, we said, hey, let's just go ahead and take the statement, I do not like chocolate, because that's the part that I need. So from there, that is called simplification. So we'll just go ahead and write S for short. Now, I guess if you need to, this is just plain old from step one. But again, if you want to write that, that's fine. If you don't want to write that, that's okay too. Part 3, we said, according to the flowchart, take your negation of C, and then also take the statement S implies C, okay, or S implies, yes, S implies C. So let's see, S implies C. So that part is going to be given, okay. So from there, we are going to get as a conclusion that it's not going to be S, okay, because again, you do not like chocolate. That is a fact. And then the other fact is that if you are smart, then you like chocolate. So the conclusion is, therefore, you are not smart. So the reason for that is supposed to be MT. Okay, so that's from step 2, combining with step 3. Okay, Now, a lot of times people get MP and MT mixed up together, so please make sure you get those memorized. One is just as is, the other one is kind of like working backwards, okay? So that's how I was able to know the difference. Okay, so continue on, we're almost done. We are going to take the next part of it, which is going to be this part right here. As of right now, we are located in this part of the proof. So we have negation of S, which we came up with already. We have S or P. So that part we grabbed from the given because that was told to us. And then finally, for step 6, it looks like if it's not S and it's S or P, then that means the conclusion is that it has to be P. So that one right there is going to be disjunctive syllogism. And that is looking at step 4 going to step 5, or combining with step 5. And there you go. That's going to be your proof. All right, so try these out yourself. Let me know how it goes, and hopefully you'll have pretty good luck with this, because it could be difficult at first when you first see it, but after a while, when you get practice, it'll get better.